Hello students, welcome again to this virtual session where we will be deriving the formula for calculating resistances in parallel. In this circuit, we have three resistors R1, R2, R3. They are connected in the parallel. Why do we say that they are connected in parallel? This is because all the three resistors have common starting as well as ending points. Let's consider these starting and ending point as X and Y. याद रखें बच्चों, पोटेंशियल डिफरेंस हमेशा दो पॉइंट्स के बीच मेजर किया जाता है. अगर दो पॉइंट्स कॉमन है, दैट मीन्स हर एक रेजिस्टर के अक्रॉस पोटेंशियल डिफरेंस भी सेम होगा. ओके, सो लेट अस से now please notice that these points X and Y are not only common for these three resistors, but also they are common for the battery as well. So if potential difference across the battery is V, then across each resistor it will be V. It will be V. Okay. We can also connect a voltmeter in parallel with the combination of these resistors, and we can measure the voltmeter. For example, if the potential difference across the battery is 6 volt, then the potential difference across each resistor is 6 volt. Okay, so now the question is, what will be the current across each resistor? For this we have to connect an ammeter with each resistor. Say you can connect ammeter here. You know that ammeter is connected in series, so you can connect ammeter here to measure the current across each resistor. We will find that current flowing in each resistor is different. Say it is I1 across R1, across R2 it is I2, across R3 it is I3. Okay. It is also observed that the total current I is equal to the sum of the separate currents through each branch of the combination. So mathematically we can write like this: I is equal to I1 plus I2 plus I3. But what we are finding actually? We are to find out the resultant resistance or the overall resistance of this parallel connection. Suppose the resultant resistance of this combination is R. Then by Ohm's law, we all know that V upon I is equal to R. Or we can also write I is equal to V upon R. Let's say it is first equation. Okay. Now since the potential difference V across all the three resistors R1, R2 and R3 is in parallel is same. So by applying Ohm's law to each resistance, we get so this is first equation, this is second equation. Now across R1, the current will be I1 is equal to V upon R1. This is 3. I2 is equal to V upon R2. This is fourth equation. And I3 is equal to V upon R3 is fifth equation. Now let's put the values of I, I1, I2, I3 in equation number 1. So what will happen? Let's see. So let's see, by putting the values, we will get V upon R is equal to V upon R1 plus V upon R2 plus V upon R3. Now taking V as common like this, we will get 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is when we took V as common. Now cancelling V on both the sides, we will get 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay. So if 3 resistors R1, R2, R3 are connected in parallel, then the resultant resistance, we can also say it as Rp, is given by the formula 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So thank you.